All right, let's be honest. You've heard the buzzwords flying around. AI, machine learning, LLMs, it's a lot. It can feel like you're supposed to know a whole new language just to keep up. But here's the good news. You don't. We're going to spend the next few minutes breaking it all down, piece by piece, into plain English. No jargon, I promise. Let's get into it.
So, here's our game plan. We're going to build this up like a set of building blocks. First, the big idea of AI itself. Then we'll get into how these machines actually learn. After that, we'll peek inside the so-called digital brain. Then we'll hit the really exciting stuff, AI that creates. And finally, we'll wrap up with a few crucial warnings you've got to know.
Okay, first up, let's lay the groundwork. We're starting with the biggest, broadest concept of them all, artificial intelligence.
So what is artificial intelligence really? I mean, we see it in the movies, we hear about it on the news, but what are we actually talking about when we say AI?
When you strip away all the hype, it's actually this simple. AI is the whole giant field of trying to get computers to do stuff that, usually requires a person. Think understanding what you're saying, making a tough call, or even driving a car. It's the big umbrella, and everything else we're about to talk about fits right under it.
Okay, so if AI is the destination, the big goal, how in the world do we get there? Well, that leads us straight to Section 2, which is all about how machines learn. This is really the engine that makes almost all modern AI go.
And this right here is a total game changer in how we think about computers. The old way, old-fashioned programming, meant a human had to sit down and write out every single rule. If this, then that. But with machine learning, we completely flip the script. We don't give the computer the rules. We just give it a ton of examples, and it figures out the rules all by itself.
So how does that actually happen? Well, it's kind of like a three-step recipe. First, you just feed the computer an enormous amount of data. We're talking pictures, articles, numbers, you name it. Then, the computer just churns through all of that, looking for patterns, connections, things a human might never even spot. And finally, based on all those patterns, it builds what we call a model, which is just its own internal rulebook that it can use to make smart guesses about new stuff it's never seen before.
So a machine is finding patterns, but what part of the machine? What's the brain in this operation? For that, we've got to pop the hood and look inside the digital brain.
And what you'll find in there is usually something called a neural network. And yeah, the name kind of gives it away. The whole idea is inspired by how our own brains are wired together. Now, obviously, it's not made of actual cells. Instead, it's made of virtual neurons that are all connected and pass information to each other in layers.
The best way to picture it is like a factory assembly line. Let's say some raw data comes in one end, like all the pixels in a photo. The first layer of workers does a super simple job, like just finding the edges in the photo. Then they pass it to the next layer, which might combine those edges into basic shapes. And it just keeps going down the line, with each layer doing a slightly more complex job until at the very end, a final answer pops out. Yep, that's a cat.
So, you've probably heard the term deep learning thrown around. What's that all about? It's actually really simple. It's just a neural network, but with a lot more layers. The deep part literally just means the network has a deep stack of these layers. It's the difference between a little workshop and a giant high-rise factory.
And why does that depth matter so much? Well, because each layer builds on the one before it, allowing for a really sophisticated understanding. So layer 1 might just see simple lines, but layer 2 can take those lines and form shapes, and layer 3 can see those shapes and recognize things like eyes and noses. And by the time you get to the final layers, they can put it all together to identify a specific person's face. It's that layering that lets AI do such amazingly complex things.
Now, this incredible ability to understand complex stuff has unlocked something pretty new, and it's the kind of AI that's been absolutely dominating the headlines. So, welcome to Section 4. We're talking about the shift from AI that just analyzes things to AI that actually creates things. And here's the difference in a nutshell. A traditional AI might look at your inbox and decide if an email is spam. It's analyzing something that's already there. But a generative AI, it can write a brand new email for you, totally from scratch. It's the difference between being a critic and being an artist.
The engine behind all this creative text is something called a large language model, or an LLM. If you've ever used something like ChatGPT, you've used an LLM. They are these massive deep learning models that have been trained on, well, basically a huge chunk of the internet, books, articles, a truly staggering amount of text. And that's how they learn the patterns and rhythms of how we humans talk and write.
Now, if you only remember one thing about how an LLM works, make it this. At its core, it's just an incredibly powerful next word predictor. When it's writing a sentence, it's just making a highly educated, statistical guess about which word should probably come next. Think of it like the autocomplete on your phone, but on a massive, almost unimaginable scale.
Okay, so we've seen how powerful this stuff is. It's amazing. But, and this is a really big but, we have to be smart about it. We have to understand where it falls short. And that brings us to our final section, the really important caveats, the rules of the road for using this tech. Let's just run through 3 key terms you have to know. First up, bias. The AI only knows what we feed it. So if our data is full of human biases, which it often is, the AI will learn those same biases and make unfair decisions. Second, hallucination. This one is wild. It's when the AI just makes stuff up, but states it with total confidence. It can sound completely right, even when it's dead wrong. So always check its work. And finally, overfitting. Think of a student who just memorizes the answers for a practice test. They'll ace that test, but if the real exam has different questions, they're toast. An overfitting AI memorizes its training data instead of learning the concepts, so it gets tripped up by new situations.
So let's just pull it all together. We basically built a pyramid of ideas here, right? At the very bottom, the huge foundation is AI, the whole big idea. The main method we use to build it is machine learning. The structure doing that learning is the neural network. And right at the very top, the exciting new point of the pyramid is generative AI, which uses all that other stuff to create something new.
And that leaves us with one last big thought to chew on. At the end of the day, this technology is really just a mirror. It learns from the vast, sprawling library of human knowledge, human creativity, and yeah, human flaws that we've created. So the question we all need to start asking ourselves is this: as we build these powerful new minds, what parts of ourselves are we actually teaching them to be?